All right, geometry. We have 1-4, perimeter and area. Going to be looking in the coordinate plane a little bit at some polygons. Polygons are just shapes with multiple sides. Again, a polygon has to have at least 3 sides, so the smallest polygon is a triangle. And if you look in your textbook on page 28, there's a pretty good list of types of polygons. Once we get past 12, the dodecagon, it's just going to be considered an entagon. For example, if it had 15 sides, you would just call it a 15agon. So the two types of polygons are convex and concave, and I just like to do an example of those just to show. I'll get that done here real quick. Convex, I like to use just a basic square. And then for concave, I like to use this good looking star here. And so I'll move that around because I don't like that being at too much of a different height. Okay, so basically what I do to determine whether these are convex or concave is if you extended the sides both ways. So I go both directions here. And I go both directions here. And I go both directions here. And I go both directions here. You will notice that neither of those directions actually went on the inside of the shape, which means it's outward and makes it convex. If I go over here, you can see right away if I'm going to do across here that space right there in the middle, right there, actually crosses into the shape, and that's what makes it concave. So extending the sides, if they don't ever actually approach the inside of the shape, that makes it convex. But if they do actually cross the inside of the shape, that makes it concave. Okay, so let's look at some different examples. Let's talk about perimeter. Obviously, perimeter is going to be adding up all of the sides on the outside, thinking of a perimeter fence. Let's go with two basic shapes. Let's deal with the triangle, and then let's deal with the square or rectangle. They're both going to be the same. And so finding the area of a triangle, I'm going to find 1/2 of the base times the height. And remember, the base and the height, just like if you were standing up next to a wall, the base and the height have to be where the 90-degree angle is. And there won't always be a 90-degree angle, so we may have to extend a side to find that. Then the area of this square or even a rectangle is going to be length times width. I have no idea why I did that one in cursive and not the other. I guess that's just the way my brain's thinking today. So we could say if this had, let's call that 4 inches. And even though it doesn't look like it, let's call that 6 inches. Let's just test it as it is, not as it looks. And so that's going to be, the area of that will be 1/2 of the base times the height, which in this case is going to be 6 times 4, 24. And that's going to be an area of 12 inches. And so if we wanted to find the perimeter of that, we could use the Pythagorean theorem, a squared plus b squared equals c squared. Let's stick with the same 4 over here, but let's go with feet. So we know if this is a square, then all of those are going to be the same. And so our area is going to be length times width. That's going to give us 16 feet. Oh, I missed this over here. I'm sorry. We're finding an area that's 12 inches squared. And this one is going to be 16 feet squared. Give those a quick circle. Perimeter of that square is obviously going to be 16 feet. Okay, so you might have to hit pause here real quick. I went ahead and drew this up. And so Now we're going to look at finding the area and the perimeter of this particular shape. And so it's a little more difficult for me to draw that square perfectly, so I'll just connect the dots like that. And we will go with that one. Now, if I wanted to find the area, I just need to find one side length. So I could do a couple of different things. I could do the distance formula that we learned in the last section. I could also break this into a bunch of triangles and find the area of those triangles. For example, I could do here to here. That would give me a triangle there. I could go here to here, and that would give me a triangle there. I could go here to here, and that gives me my third triangle. And then I could go, whoop, I don't like that one. I could go right there. Now, we're going to treat this quadrilateral, and while it looks like it is a square, we're going to treat it like we don't know it's a square, and we're going to find the area of each of those triangles. So I have, let me show you the different ones that I have. I have a triangle here. I have another triangle here. I have a third triangle here. A fourth triangle here. And then I have this space in the middle. So I'm going to look at the yellow triangle, and I can see that it has a height, 1, 2, 3, of 4, and a base of 3. So that area is going to be 1/2 of 4 times 3, which is 12, giving me 6. So that one is done. The next one should be the same thing. It is also 4 by 3. And so the area of the green one is 6. It just so happens, as I look at this, this is going to be a perfect square. We may not have known that, though. And then the next one is also 6. And the purple one is also 6. So that gives us a total of 24. And then we have the square in the middle, which is a 1 by 1. So we now have an area of 25 units squared, or square units. Now, we could use Pythagorean theorem, that is a 3 and a 4, to find the outside. So we have c squared equals 3 squared plus 4 squared. That's c squared equals 9 plus 16. C squared equals 25, which means our outside distances are all 5. And I could use that to find my perimeter, which is now 5 times 4, which is 20 units. Yikes, my handwriting just got bad all of a sudden. Okay, so that takes care of area and perimeter. And that is all for Chapter 1, Section 4, Perimeter and Area in the Coordinate Plane.